Welcome to Kaiju Mathematics. Today I will be estimating a population mean. So with the population mean, you want to make sure you know when are we using the normal distribution and when are we using the t-distribution. So the population mean is a t-distribution. Students' t-distribution is what we're going to be using. And I have the t-distribution here. In any sort of stats class you take, any sort of textbook, you'll be provided with the t-distribution in the back of the book. I just took half of it here out of the textbook that I use with my classes. The way we read the t-distribution, and I'm not going to go into a whole background on the t-distribution or anything. I really want to just focus on creating the estimating a population mean, so creating the interval. But the way you read this table is the area in the right tail is across the top, and then the degrees of freedom is down the side. So estimating a population mean, what we want to do is we want to get a point estimate, which is going to be x bar in this case, since we're trying to estimate a population mean. So we have sample data, so we're going to get the sample mean, and then we want to create an interval around it, which is going to be the margin of error. So x bar plus and minus the margin of error. Margin of error is found by taking your critical value from your t-distribution, so t sub alpha divided by 2, times the sample standard deviation divided by the square root of the sample size. So S stands for the sample standard deviation. So S is your sample standard deviation. And when we're trying to estimate a population mean, most of the problems, I'm not going to say all of the problems that you'll see, most of them, though, will give you the data. So in this problem, I have Mario has made appearances in over 200 video games. The following data is the number of games 8 people have played with Mario in it. A normal probability plot suggests that the data could come from a population that is normally distributed. So we just have this data here. What we need from this data is we need x bar, sample mean, and we need sample standard deviation from this data. And what we want to do is we want to construct a 95% confidence interval. The level of confidence will come into play when we get our critical value from the t-distribution. So just to save some time on this video, so you're not sitting here watching me hit buttons on my calculator here, I went ahead and got the mean. The mean comes out to be 8.5, and you could do this in your calculator. There's ways to do this. And then the sample standard deviation is 2.27. Next, we need to get our critical value. So here's how we navigate that process. And we might as well actually write down the sample size and degrees of freedom here. Sample size is 8. We sampled 8 people. So our degrees of freedom then is 7. Degrees of freedom is found by taking your sample size minus 1. So degrees of freedom is 7, and degrees of freedom is used in the t-distribution right here. It's a little bit bigger. Degrees of freedom is down the, will tell us which row to look in depending on degrees of freedom. So we have to get our critical value. Our first part we want to establish is our alpha. Alpha is going to be 1 minus the level of confidence that we want. So we want a 95% confidence level. So alpha is going to be 1 minus 0.95. 1 minus 0.95 is 0.05. So we want t sub 0.05 divided by 2, t sub alpha divided by 2. We just calculated our alpha to be 0.05, so t sub 0.05 divided by 2, and that's going to come out to be 0.025. So we want t sub 0.025. So the area in the right tail, when we go to our t-distribution, is going to be 0.025. The degrees of freedom is going to be 7. So this tells me which column to be looking in. This tells me which row to be looking in. So I'm going to go to 0.025, degrees of freedom, 7. 0.025 is right here. Degrees of freedom is 7 right here. And we just match it up like a vending machine. Like if I want this Snickers bar right here, I just go zoop, and then zoop. This could be 2.365. So the critical value, 2.365. Let me get myself out of the way here. Always in the way. All right, cool. So now we just have to get our margin of error. So margin of error is going to be that critical value, 2.365 times the sample standard deviation. sample standard deviation was found from my calculator, 2.27. So 2.27 divided by the square root of the sample size, which is 8. Don't confuse that square root of the sample size with degrees of freedom. Make sure you are putting in the sample size for that part of the formula, square root of n, so square root of the sample size. So this is just hitting buttons in your calculator, so 2.27 divided by the square root of 8 times 2.365, and we get a margin of error of 1.898. So I'll just put 1.9. So 1.9. That means our confidence interval then is going to be x bar plus and minus the margin of error. So I'll just do it right here. Let me do it in black. So x bar 8.5 plus and minus the margin of error. So the interval is going to be 8.5 minus 1.9, which is 6.6, and then 8.5 plus 1.9, which is 10.4. So there is our 95% confidence interval for the population mean. Hope this video helps with estimating a population mean. If you like this content, please consider hitting that subscribe button, and thank you for watching.